In this discussion video, we will do some chain rule practice that involves trig and exponential functions. So recall that we know the derivative of e to the x. Derivative of e to the x is itself, it's just e to the x. But we also know how to do the derivative of e to the stuff using the chain rule. So for the derivative of e to the stuff, let's remember how we derive this. This has an outside function and an inside function and an inside function. So usually when we think about e to the x, the thing that's getting plugged in is plugged into this exponent. Okay, so with e to the stuff, what's getting plugged in is the stuff. So my inside function is this stuff. So I will write g of x equals the stuff. And what it's getting plugged into is the exponent of e to the x. So my outside function, I'll call it f of x, is e to the x. All right, and now when we do the chain rule on e to the stuff, the chain rule says, well, take the derivative of the outside function first, which is e to the x. But the chain rule says, wait, don't plug x into it. Keep plugging in the same inside thing. So keep plugging the stuff in for the variable. All right, so we will have e to the stuff. And then the chain rule says, well, multiply that by the derivative of the inside thing, the derivative of the stuff. So the derivative of the stuff. So the key takeaway is, if I want to do the derivative of e to the stuff, the chain rule says, oh, it's e to the stuff times the derivative of the stuff. So let's look at an example. So this first example is not from one of our worksheets. It's just a separate practice problem. We have the derivative of e to the, and the exponent is 7x to the third plus tangent of x. Pause it for 2 minutes to try this on your own. 4, 3, 2, 1. 2-minute pause to try this. All right, let's talk about it together. So this derivative, using the chain rule, should be e to that stuff. So e to the 7x to the third plus tangent of x. Let me put a big old parentheses around this so I know that that whole thing is an exponent. But the chain rule says, well, then you got to multiply by the derivative of the stuff. So for 7x to the third, that's power rule. I'll get 21x squared, and the derivative of tangent of x is secant squared. So I get plus secant squared x, and close that parentheses, and that is my derivative. All right, let's look at another practice problem. This one's from the worksheet, from worksheet 6, and I want to look at 9, first part g, which is f of x equals e to the, and the exponent of the e is e to the 1 over x. So we want to evaluate this derivative. First, give yourself 2 minutes to try this. 4, 3, 2, 1. Pause it and try this one for 2 minutes. All right, let's talk about it together now. So when we take this derivative, we have e to the stuff. The stuff is all of this. This is the exponent of that first sort of outermost e. So chain rule says, well, you'll have e to the stuff, in this case e to the 1 over x. But then we'll have to multiply by the derivative of that stuff. So over here, we're going to have to write the derivative of e to the 1 over x. And this is also e to the stuff, so I'll need chain rule again. And the chain rule, again, will say, well, the derivative of this thing, e to the 1 over x, is e to this stuff, e to 1 over x, but multiplied by the derivative of that stuff, the derivative of this 1 over x. And to do that derivative, I should rewrite 1 over x as x to the negative 1. And then this is just power rule. Power rule will say, okay, the derivative of that is negative x to the negative 2. All right, and that is my answer. That is what we get using the chain rule, in this case, twice. All right, if I did need to simplify this, I could rewrite this as negative 1 over x squared. All right, let's do another practice problem. Let's do f now. So we have sine of in parentheses. So we have a big parentheses here. We have e to the x to the 4 minus 2x, and then plus cosine of x to the third. That whole thing is inside the sine. So give yourself 3 minutes to try this. 4, 3, 2, 1, pause it, and try this one for 3 minutes on your own first. All right, so hopefully you've done that. Hopefully you paused it and tried it for about 3 minutes. So I need chain rule for this first. Okay, we need chain rule because we have this whole thing, all of this being plugged into this outside sine function. So the chain rule says we'll take the derivative of the outside first. Derivative of sine is cosine. But when you do that, keep plugging the same inside thing in. So keep plugging in e to the x to the 4 minus 2x, and then plus cosine of x to the third. Keep plugging that in. And then do the chain rule step and multiply by the derivative of that inside stuff. Okay, so I'm going to give myself a lot of space here. So for the derivative of this e term, I need chain rule again, and I'll get e to that stuff, e to the x to the 4 minus 2x, times the derivative of that stuff, the derivative of this exponent, derivative of that, which will be 4x to the third minus 2. Okay, and then for the next term, cosine of x to the third, I need chain rule again, because it's cosine of not just x, cosine of some more complicated stuff. So if I do the derivative of the outside of the cosine, that derivative is negative sine. But the chain rule says, well, keep plugging the same inside thing in, keep plugging in x cubed. Then just do the chain rule step and multiply that by the derivative of the inside of that x to the third, which is 3x squared. And now let's close this bracket. And that is our answer. That is what we get using the chain rule a couple of times on this. All right, let's do another practice problem. It's really just the best way to get comfortable with chain rule is to do a bunch of practice problems. All right, so for the next one, I want you to pause this for 2 minutes to try it first. 4, 3, 2, 1, pause it. Just a quick 2 minutes to pause and try this. All right, so hopefully you did that. Hopefully you paused it and tried it for about 2 minutes. Let's talk about it together. So here as well, I have this trig function on the outside, and then I have some stuff. In fact, I have two things multiplied on the inside. So I'm going to need chain rule. At least first I'll need chain rule. All right, and when we do this, we will end up with, so the derivative of the outside function, the derivative of the secant is secant tangent. So I will get secant, leave a little space, tangent, leave a little space. But instead of just writing secant x, tangent x, the chain rule says, okay, when you do that derivative, keep plugging in the same inside thing, which is sine x times e to the negative x. In here as well, because this is just part of the derivative, keep plugging in the same inside thing. But then we do the chain rule step, in which we now multiply with the derivative of the inside thing. Derivative of sine x e to the negative x. All right, so you may have noticed that we're kind of running out of room. And that was kind of by design, because at this point, what's left to do is to take this derivative, and I have two functions multiplied, so this is a product rule. And I think this is great practice, so I want to leave it for you to finish. I want to leave this one for you to finish.